Yes, we are taking a subtopic, HCF of numbers, that will eventually lead us to HCF of letters. First, let's have some few examples. Find the HCF of 24 and 60. The options: A, 2, B, 3, C, 4, D, 6, E, 12. Solution: HCF of 24 and 60. Let's roll our lines and impute the values. 24, 60. This is HCF, so care must be taken. Any number we are using to divide, any prime factor number we are using to divide, it must divide through the given values. When we look at it carefully, you can see 2, first prime number there. 2 can divide. 2 divide 24 will give you 12. 2 divide 60 will give you 30. Yes, we can still take 2. By careful observation, 2 can still go divide through. 2 divide 12 will give you 6. 2 divide 30 will give you 15. A careful observation will show that the next number 2 cannot go through, divide the 2 giving result. But 3 can. So we apply 3. 3 divide 6, give you 2. 3 divide 15, give you 5. This is HCF, so we stop there. No other number can divide through the 2 given result. We now conclusively say HCF of 24 and 60 is equals to 2 times 2 times 3, which is equals to 12. Let's take another example. Find the HCF of 24 and 40. The options are given: A, 12, B, 10, C, 8, D, 6, E, 4. Solution: HCF of 24 and 40. Let's roll our mini table and insert our value 24, 40. We are dealing with HCF, so care must be taken. Any number we are choosing to divide through, prime factor we are choosing to divide through, must be able to divide the 2 numbers, the 2 available values, or more, depending on what we are given. Must divide them without remainder. And in this case, 2 can divide 24 and 40. 2 divide 24 will give you 12. 2 divide 40 will give you 20. If you look at the resultant value, 2 resultant value, 2 can still divide through. 2 divide 12 will give you 6. 2 divide 20 will give you 10. Yes, our resultant value, with careful observation, you can see that 2 can still divide through. 2 divide 6 give you 3. 2 divide 10 give you 5. We can't proceed any further because the remaining 2 values, we don't have a common number that can divide 2 of them without remainder. So HCF for 24 and 40 is equals to 2 times 2 times 2, which is equals to 8. Another example. A part of the question: factorize the numbers 77, 777 and 7,777 respectively. The B part of the same question: using your answer in A above or otherwise, find the HCF of 77, 777 and 7,777. Solution: A part. To factorize here means bringing out the common factor. Let's roll our line as we do in our HCF and introduce our values. 77, 777, then 7,777. When you look at your given value carefully, see that 7 can divide through. First prime factor then that can divide through is 7. So 7 divides 77, give you 11. Divide 777, give you 111. And 7,777 divided by 7 will give you 1101. The B part of the question. HCF of 77, 777 and 7,777 from the above is 7. Let's take another example. Find the HCF of 15 and 36. A 30, B 300, C 3, D 6, E 2. Solution. HCF of 15 and 36. Let's rule our line and we impute the values 15 and 36. When you look at the values carefully, this is HCF, so we don't just rush into picking factors. A factor that we must pick must divide the two given number, or if it's 3, depending on the case, it must divide them without remainder. And here is 3 that can do that. 3 divide 15 will give you 5. 3 divide 36 will give you 12. We stop there because no other number factor we are picking to divide through that there won't be a remainder. So HCF of 15 and 36 is equals to 3. Let's pick another example. Find the HCF of 504 and 588. Option A, 84. B, 24. C, 42. D, 96. E, 48. Solution. HCF of 504 and 588. Let's rule our line and impute the values. 504 and 588. Any number we are picking should be a number that can divide through without a remainder. And here, the first number we pick here is 2. 2 divide 504 will give you 252. 2 divide 588 will give you 294. A careful observation will show that 2 can still divide through the given numbers. 2 divide 252 will give you 126. 2 divide 294 will give you 147. If you look at the given resultant value very carefully, you will observe that 3 can divide through. 3 divide 126 will give you 42. 3 divide 147 will give you 49. The resultant value, if we look at it carefully, 7 can still divide through. 7 divide 42 will give you 6. 7 divide 49 will give you 7. That is how far we can go. If we pick any other number to divide through, any other prime factor to divide through, we have remainder. You cannot divide the two numbers. So HCF of 504 and 588 is equals to 2 times 2 times 3 times 7. That is equals to 84. That is the last example on this subtopic HCF of numbers. We'll be treating some exercises from page 64 of our hidden fact in JSSC mathematics. The exercises have the answers at the back of the book, either the soft copy or the hard copy. Thank you.